Hello students, welcome to Educate. In this class, we will discuss about amines. Firstly, what is amines? So you already know ammonia. What is ammonia? NH3, ammonia. So this NH3, here NH3 from here, when one hydrogen will remove, that is NH2. Then when one hydrogen will remove, then this function, the octet of nitrogen will the octet of nitrogen will become unstabilized. So this will act as a functional group. So it is called amino group. NH2 is amino group. That means here NH2, when from ammonia, when you remove one hydrogen, then the group formed is called amino group. And when this amino group will be bonded to the open chain hydrocarbon or the closed chain hydrocarbon, then the compound will be called amine. Like that, here this compound here. So it will be called amine. So amine is the compound in which the amino group, that is NH2, will be bonded to the open chain hydrocarbon or to the closed chain hydrocarbon. That was introduction. That's amine. What is that? About their application, that means in this book when you will study, then that will be very informative points you will get, and that will be applicable for not only for the examination of the 12th level but of the graduation level also. About that we will discuss later on also. So let's see. Now then after is, that was the amine. What is that? Then after is a structure of amine. Okay, first of all, predict what is the shape of ammonia. Shape of ammonia, what is that? Recall that. Let's see. Think. 1 minute. I am giving you the time. Listen, in the case of ammonia, draw the structure like this one. Here 3 sigma bonding to 3 hydrogen is bonded to 1 nitrogen. So shape should be trigonal planar. Shape would be the trigonal planar, as in case of BF3 or BH3. Same here ammonia. In case of ammonia, that means 3 hydrogen atom. The 3 hydrogen atom bonded to the nitrogen will arrange so that there will be minimum repulsion between the hydrogen atoms. But there is a lone pair of electron at nitrogen. This lone pair of electron. So this lone pair of electron will repel the 3 hydrogen. This bond pair of electrons, this lone pair of electron will repel this bond pair of electron. As a result, the shape become here trigonal planar. Let's see about this one. Suppose my finger, this one here is my hands. This one is nitrogen. So hydrogen like that. Here hydrogen, and here hydrogen. Like this one. Shape would be like this. Initially, the 3 hydrogen will lie in 3-dimensional space, so that there will be minimum repulsion between this one. So that would be here 120 degree angle would be 120 degree, but actually not. What is here? Since there is a lone pair of electron at the nitrogen, so this lone pair of electron will repel this bond pair of electron to this bond pair of electron and to this bond pair of electron. So along with that, hydrogen will also go. So what will happen? The three hydrogen, this hydrogen, this hydrogen, this hydrogen, this three hydrogen atom will lie on the same plane, and the nitrogen atom will be above to that plane. So when you join the center of this hydrogen atom, there will be formation of a triangle, and nitrogen will be above to that triangle. So when you will join this hydrogen to this hydrogen to this nitrogen, and this hydrogen to this nitrogen, the shape will be like a pyramid. So that's why the shape of ammonia is trigonal pyramidal. That means the shape will be pyramidal, in which the base will be triangular. Okay, so that is here. Shape here is triangular, trigonal, planar. Oh, sorry, trigonal, pyramidal. So this one not shape here, not planar, trigonal, pyramidal. So shape of ammonia is trigonal, pyramidal. In the same way here, when we have to find out the shape of this nitrogen here around this amino group. So lone pair of electron here. So it will repel this bond pair of electron, this bond pair of electron, and this bond pair of electron. So here the carbon atom, in this case, in case of methylamine, the carbon atom will be here, the hydrogen and this hydrogen. That means the carbon, hydrogen and this hydrogen, the two hydrogen and this carbon will lie on a single plane, and nitrogen will be above to that plane. So here shape will be also trigonal, pyramidal around this functional group. Around this functional group, the shape will be trigonal, pyramidal, as was in case of ammonia. So shape will be tri here at this end. At this end, the shape will be trigonal, pyramidal. Okay, guys. So that is here. That has been shown in this case here. Unshared electron, this shared pair of electron that repel the bond pair of electron. So this hybrid orbitals will lie in this plane. Okay, what's the hybridization here? Watch out, as I have told you the shape, but what will be the hybridization of nitrogen atom? So when you will have to find out the hybridization, so whenever you will have to predict the hybridization of a molecule, of a central atom or any atom, when you will have to predict about the hybridization, then you will have to watch out that that atom is forming how much sigma bond and how much lone pair of electron it contains. The hybrid orbital either do sigma bond formation or contain the lone pair of electron. So about this nitrogen here, this nitrogen is forming 3 sigma bond, 2 with hydrogen and 1 with carbon. In addition to that, it also contains a lone pair of electron. So to this nitrogen, there will be requirement of 4 hybrid orbital. Since the nitrogen will have to form 3 sigma bond and will have to contain a lone pair of electron. That's why this nitrogen atom need 4 hybrid orbital. To form 4 hybrid orbital, the 4 atomic orbital of nitrogen will have to merge together, out of which one will be S and the remaining 3 will be P. So hybridization of nitrogen, in this case amine, will be sp3. Okay, so hybridization here is hybridization of nitrogen is okay. What it forms 3 sigma bond, the 3 sigma bond and contain a lone pair of electron. Okay, I think everyone everyone who is watching this video and have watched my other videos feel too much easy about this one. That is just like the time pass, just for it, fulfilling the formalities. So here one hybrid orbital contain lone pair of electron and one hybrid orbital do sigma bond formation here, one hybrid orbital sigma bond formation here, sigma bond formation. So shape here is trigonal and here, so that means watch out here on the two, it is two-dimensional figure. Might be someone feel difficulty. What is about this one? So this here, this is of CS3, CS3, CS3. That means here is nitrogen, there carbon here, and this carbon atom. These three carbon atoms lie here. So that is indicating here. So when formed, so it will be when C with CS3. So this will be the hybrid sp3 hybridized orbital, in which the sp3 hybridized orbital of the carbon atom have done head-on overlapping and form the sigma bond. So this one is here. These three hybrid orbitals are on is like this. This three hybrid orbital is like this, and the four hybrid orbital which will be here, that will contain the lone pair of electron like this. Two-dimensional figure here. So might be someone feel difficulty. Actually, which is not difficulty here. Which is not here any difficulty, matter of difficulty. Here carbon, nitrogen here, carbon, carbon, carbon here. This is sp3 hybridized orbital. So that is here. This sp3 hybridized orbital. This is sp3 hybridized orbital. This one has been indicated, and this sp3 hybridized orbital. This one has been indicated. And the hybrid orbital which have not done sigma bond formation, that will contain lone pair of electron. So here the lone pair of electron has been given here. Okay, lone pair of electron, that's also called unshared electron pair. So lone pair of electron means unshared electron pair. That means the electron which has been not participated in bond formation. Then after, let's see. That was about shape. Now then after is classification of amines. Classification, guys, the classification of amine is different from that of the haloalkane, haloarine, as well as from the alcohol. In aldehyde and ketone, the classification was not there because there was only CHO and C double bond O. Okay, so that can be classified on the basis of like uses and like that, which is not in your syllabus. Now, when we will have to classify the amines, we don't classify that it is alkyl amine or aryl amine or benzyl amine like that. Here is 1 degree, 2 degree and 3 degree amine. Like there is difference between 1 degree, 2 degree and 3 degree amine in the case of amines compared to that of the haloalkane or the alcohol. In haloalkane or alcohol, how we have classified the 1 degree alcohol or 1 degree haloalkane, that if the halogen functional group is bonded to 1 degree carbon atom, then that will be 1 degree haloalkane or 1 degree alcohol. 2 degree alcohol means the halogens, that is functional group, that is halogen or the OH, when bonded to secondary carbon atom, then that was called 2 degree haloalkane or the 2 degree alcohol. Same 3 degree haloalkane or 3 degree alcohol when the functional group, that is halogen or the OH group, was bonded with 3 degree carbon atom, then we called them as 3 degree haloalkane or the 3 degree alcohol. But in case of amines, here it is required that how much hydrocarbon is bonded to the nitrogen. If only one hydrocarbon will be bonded to the nitrogen, then that will be called 1 degree amine. Same way, if two molecules of hydrocarbon will be bonded to one nitrogen, then that will be called secondary amine or the 2 degree amine. In the same way, if three molecules of hydrocarbon will be bonded to one nitrogen, then the compound will be called 3 degree amine or tertiary amine. As for example, let's see. in this compound only one alkyl group is bonded to the nitrogen. So that's why this amine is called 1-degree amine or primary amine. Here nitrogen, if two hydrocarbon will be bonded, like this one and this one. So two hydrocarbon is bonded to one nitrogen, that will be called 2-degree amine or secondary amine. In the same way, here's nitrogen and 3 alkyl group if bonded there. 3 hydrocarbon present there. So that was called tertiary amine or 3-degree amine. That you call 3-degree amine or tertiary amine. Clear? That is classification here. This one 1-degree, 2-degree and 3-degree amine is classified on the basis of that how much hydrocarbon is bonded to one nitrogen. If only one hydrocarbon will be bonded to one nitrogen, then that will be called 1-degree amine or the primary amine. If the two hydrocarbon molecule will be bonded to a nitrogen, then that amine will be called secondary amine or 2-degree amine. And if there will be 3 hydrocarbon bonded to one nitrogen, then the compound will be called 3-degree amine or tertiary amine. Okay guys, that was about classification, which is very easy in this case. As the classification in haloalkane and in case of alcohol was also not difficult, but here the classification of amine is something different from that of the haloalkane or from the alcohol chapter. Okay, now let's see, that was about the classification. Now let's see the nomenclature. Nomenclature here, rules will not ask in the examination, questions directly ask. Write the IPAC name. So let's see, we watch out in the example of NCERT book and how that has been written. So let's see. It is 1-degree amine here. Here NH2 group is bonded to ethyl group. So common name, very simple, alkyl amine. In common name, we will have to write alkyl amine. And when we will have to write IUPAC name, then that will be of alkane, E will replace by the amine. Okay, where there will be exception, I think you can also predict, and maybe that means if more than one amino group will be there, then the E will not replace. About that, I think you could predict. That is, so now by one we write the IPAC name. So here two ethyl group, here is ethyl group and nitrogen, NH2 amino group is bonded. So common name will be ethyl amine. So that's why the name is ethyl amine. Amino group is bonded to ethyl group, so that's why ethyl amine. And IUPAC name, ethane, from ethane, that is, it is ethane, E has been replaced by the word amine. So that's why the name is ethane amine. Here propane, here it is an amino group, so that's why here the in common name sometimes end this word mentioned, that indicate that the functional group is bonded to 1-degree hydrocarbon and means normal. So that means the functional group is bonded to an 1-degree carbon atom. If that is secondary, then that will be called iso. So let's see here. So in this case, Here the amino group is bonded to the secondary carbon atom of propane. So that's why it is called isopropyl amine. Here it is called N-propyl amine because amino group is bonded to the 1 degree carbon atom. So that's why the compound will be called N-propyl amine. And IUPAC name when you will have to write. So alkane and amine. So it is propane. Of this propane, E has been replaced by the word amine. So that's why it is propane 1 amine. And in second case here, the functional group is bonded to the 2 degree carbon atom. The functional group is bonded to 2 degree carbon atom here. So it is, when you write a common name, then it is isopropyl group. This one is isopropyl group because the secondary carbon atom is doing bond formation to the functional group. So it is isopropyl group and here it is amino. So that's why isopropyl amine. Isopropyl amine is like that, due to that. And when you will have to write the IUPAC name, then how you write the IUPAC name? So this is the carbon atom which is bonded to the functional group. So this carbon atom must be included. This carbon atom must be included in the main chain. So you will have to select that longest carbon chain which will contain this carbon atom. So that is 1, 2, 3. Or if you do the numbering from left to right, then also 1, 2, 3. So from both the sides, functional group is bonded to secondary, that means a functional group is at second carbon atom. In both the cases, the functional group is acquiring the second position. So that's why in this case, from any side, we can do the numbering. So I have done the numbering from left to right. So amino group is at second position. So that's why we will write propane. Of propane, this one, E will replace from here by 2 amine. So that's why name is propane 2 amine. E will replace by amine. Now in this compound here, watch out here. It is secondary amine. This molecule was 1 degree amine. This was 1 degree amine. It was also 1 degree amine because only one alkyl group is bonded to the nitrogen. So it is also 1 degree amine. This is also 1 degree amine because to the functional group, only one alkyl group is doing bond formation. So it is also 1 degree amine. But this molecule is here. This molecule is this molecule. This molecule is not 1 degree amine because with this nitrogen, the 2 alkyl group is doing bond formation. So the 2 alkyl group is doing bond formation. That's why this amine is the 2 degree amine. Since 2 alkyl group is doing bond formation with nitrogen, that's why this amine will includes in 2 degree amine. Now, how to write the IUPAC name? So, during IUPAC name, firstly we will have to consider about the length of the alkyl group. This alkyl group is of 2 carbon and this alkyl group is of only 1 carbon. This alkyl group is of 2 carbon and this alkyl group is of 1 carbon. So, we write we will use the suffix amine in that alkyl group which is longest here, provided that there is no any other functional group. If the 2 alkyl group will be bonded to a nitrogen, then that amine will classified into the secondary amine, and to write their IUPAC name, the alkyl group having smaller length will consider as substituent and the alkyl group having the longest carbon chain that will act as parent chain. So this amine, this will act as substituent and this ethyl group will act as parent chain. So amine will, the suffix amine will used in that alkyl group whose length is longest. So here nitrogen is bonded with nitrogen. The methyl is bonded, so we will write N-methyl. Why N-methyl? Because methyl group is bonded to the nitrogen. So that's why N-methyl, and here is ethane and amine. So in ethane, we will have to use the word amine. So ethanamine. That's written N-methyl ethanamine. Now in this compound here, in this compound, three alkyl group is here. In this compound, the three alkyl group is doing bond formation with a nitrogen atom. Here, this alkyl group, this alkyl group, this alkyl group. Three alkyl group is bonded to a nitrogen. So that's why this alkyl group, this amine, will classified into 3-degree amine. 3-degree amine or tertiary amine. IUPAC name, when you will have to write the common name, then we consider about, okay, here also I have not taught you the IUPAC name. Whenever common name, whenever we will have to write the common name of secondary amine or tertiary amine, then we will have to consider about alphabetical order. And when we will have to write the IUPAC name of amine, then we will have to consider about the length of alkyl group. So here in this compound, in the previous one, this one here, it is ethyl, it is methyl. So it starts from E, and here methyl, it starts from M. So E alphabetical order, E comes first, then after M. So that's why it is ethyl methyl amine. We will write the name of the alkyl group according to their alphabetical order. So it is ethyl, it is methyl. So that's why it is ethyl and methyl, and then after amine. We will write the name of the alkyl group on the basis of their alphabetical order. Now here also we will have to write, in this case it is methyl, every alkyl group is methyl. So 3-methyl group is bonded to the nitrogen. So that's why we will write trimethylamine. Trimethylamine. And when we will have to write the IUPAC name, then one alkyl group here, since this 3 alkyl group is of same length, so one alkyl group will consider as parent chain and the other will be as substituent. So a methyl group and a methyl group, the 2-methyl group is bonded to the nitrogen. So we will write N dimethyl. So that's why N dimethyl. And then after here, it will consider as substituent. So methane of methane, E will replace by amine. So that's why methane amine. Now let's see this compound. To this nitrogen, this ethyl is attached, and this butyl is attached. So this is also 3-degree amine, or it is tertiary amine. When we will have to write the common name, then we will have to consider about the alphabetical order. Okay, so let's see here, but here this one is the longest carbon chain, so it will be N diethyl and butanamine. This one, when we will have to write the IUPAC name, so here we will have to write the position. So that's why N diethyl butane 1-amine. Okay. Now let's see the IUPAC name of this compound. So here functional group is bonded to this carbon atom. This is the chain. And for amine we uses the suffix, and amine is senior functional group than that of the alkene or alkyne. So that's why when we will have to do the numbering, then we will have to give lowest position to the amine. If here we will have to give lowest position to amine. So what to do? So that's why here 1, 2, 3. That is for the IPAC name. I am telling IPAC name. First of all, watch out alphabetical order. So 1, 2, 3. This one here at second position there is double bond. So it is prop 2 in here, and amino group is at first position. So that's why amine. So prop 2 in amine, or you may write either this one or prop 2 in 1 amine. Whatever you would like to write, you write that. So IPAC name of this compound is prop 2 in amine or prop 2 in 1 amine. And I have taught you a number of times. I have told you that when the carbon atom here functional group is bonded to that carbon atom whose hybridization is sp3. Here the functional group is bonded to that carbon atom whose hybridization is sp3, and that is bonded to sp2 hybridized carbon atom. So that's why common name is allyl amine. That group is allyl group because this carbon atom is bonded to the functional group. So that's why this group is allyl group. So that's why it is called allyl amine. Common name that was. Now let's see about this compound here. So what is happening here? This side NH2 and this side NH2. So main chain is of 6 carbon atom, and the nitrogen is bonded to the terminal end. So obviously one amino group will be bonded to the first carbon, and the another amino group is bonded to the 6th carbon atom. So one amino group is at first carbon atom and second amino group is at 6th carbon atom. So that's why 1,6-diamine will be there. Main chain is of 6 carbon, in which the 2 amino group is bonded at first and the 6th carbon atom. So that's why of hexane E will retain here. Watch out here. Be careful. E has been retained because there is 2 amino group. In the compound, there is 2 amino group. That's why E has been retained. And main chain is of 6 carbon. So that's why hexane and one amino group is at first position and the second amino group is at 6th position. So that's why written 1,6-diamine. So that's why name of the compound is hexane 1,6-diamine. Be careful here. Since 2 amino group is there, that's why E has been attained. E has been retained here. Okay. Now let's see this compound. Yeah, when a number of times I have told you, when NH2 is bonded to the benzene, then compound is called aniline. And aniline is the common name. Nowadays, the aniline name has been adopted by the IPAC system of nomenclature. So in IPAC system of nomenclature also, its name will be aniline, and in common system of nomenclature also, its name will be aniline. So here NH2 group is bonded to the benzene. So common name is aniline and IPAC name is aniline, or you may write benzenamine also. So benzene of benzene, E will replace by amine. So that's why the name has become benzenamine. E has been replaced by amine. Now same here. Now this compound. What about this compound? Here amino group is bonded to this carbon and bromine is bonded to this carbon. So when you will have to write the IPAC system of nomenclature, then you will have to consider that when you will have to write the IPAC system of nomenclature, then you will have to watch out here. since this whole is called aniline and bromine is at present at para position. Ortho meta para we will use in the name of the compound during common system of nomenclature, and the number we will in during the IPAC system of nomenclature we will have to mention about the number of carbon atom to which that group is bonded. So here when we will have to write the common name, then we will have to consider that this one is functional group carbon here, so it is para position. This is, and this one is ortho. This two is meta and this one is para. So bromine is present at para position. So that's why we will write para bromo aniline. That's why written para bromo aniline. And when we will have to write the IPAC name, then we will have to consider about this one here, that amino group is senior, so it will be at first position. So 2, 3, 4. When we do the numbering in clockwise direction, then the bromine has acquired fourth position. And when we do the numbering in anti-clockwise direction, then also the bromine will get fourth position. So it is for this carbon is first, so second, third, fourth. So that's why 4 bromo and aniline it is. So 4 bromo benzenamine or 4 bromo aniline. 4 bromo aniline, or that's also called benzenamine here. So that's why 4 bromo benzenamine. Okay. Now watch out this compound here. So firstly I am drawing here structure. So 2-methyl group is bonded here. So it is aniline here, but the 2-methyl group is bonded here. So that's why it will be called, will be considered as N dimethyl aniline. And in IPAC name also, and as well as in common name also. That is N dimethyl aniline or N dimethyl benzenamine or N dimethyl aniline. Anyone you can write. N dimethyl benzenamine or N dimethyl aniline. That was. Okay. That's done. Now let's see about this compound. Classify the following primary, secondary, or tertiary. So in this compound, only one alkyl group part is bonded. Only one hydrocarbon is bonded to the NH2. So that's why it will be 1 degree amine. In this compound here, the 2 alkyl group is bonded to nitrogen and one this group. So 3 hydrocarbon, total 3 hydrocarbon is bonded present here in this compound. That's why it will be also included in 1 degree amine, or that will also called primary amine. It's very simple here. In this compound here, the 2 ethyl group. Okay, I am drawing the structure of this compound, and then after you will realize directly it can be also stated that is 1 degree amine. But here let's see how to draw the structure. So here 2 ethyl group in this compound. Watch out here. In this compound, the 2 ethyl group is bonded to 1 carbon, and to that carbon the amino group is bonded. So here it is, this is a carbon, this is a carbon here, the amino group is bonded, and the 2 ethyl group is bonded here. So C2H5 and C2H5. So this carbon is a tertiary carbon. Okay, no, secondary carbon. But the classification of amine is different from that of haloalkane or from the alcohol. Here only that is depending on that how much alkyl group is bonded. So this only one alkyl group is bonded to the nitrogen. This whole is one. Through secondary carbon atom, one alkyl group is bonded to the nitrogen. That's why it is 1 degree amine or primary amine. Okay, and so that is 1 degree amine or primary amine. Now let's see about this molecule here. In this molecule, the 2-ethyl group is bonded to the nitrogen. That means here nitrogen, here one hydrogen attached, and 2-ethyl group. So C2H5, this one, and C2H5. 2-ethyl group is bonded to the nitrogen. So that's why it will be included in 2 degree amine or secondary amine. Or that is also called, okay, or sec amine, whatever you would like to write. This one. Okay, guys, I think it's clear for you. This question. Now again we proceed to the next question. You will have to keep in the mind for the classification of amine that how much alkyl group or how much hydrocarbon is bonded. How much hydrocarbon is bonded to the nitrogen. Okay. Now about this question, let's see. This compound here, molecular formula is this one, molecular formula is this one, and you will have to draw the structure. Okay, I think you will have to write IUPAC name of all the isomers, what type of isomer is exhibited at different pairs of amines. Okay, this one. So let's see. Keep in the mind that molecular formula is C4H11N. So let's see here. One is that amine. So its IUPAC name is what? It is 1 degree amine, and here 1 degree amine it is, and IUPAC name. So simple, butane. E will replace by amine. So butane, amine, butane, 1 amine. That you can write. Okay. Same way here. In the benzene, you can take one methyl group from here and attach to this carbon. Then the structure will be, so main chain will be of 3 carbon, in which, and at this carbon, one methyl group will be there, and here an H2. Now maintain the valency. How to write the IUPAC name? So functional group is bonded to this carbon. So this will be, functional group is bonded to this carbon. So that's why this carbon will get the first position. So this carbon will be given one carbon, one number, this second, and this is third. So methyl group is bonded. Main name will be propanamine. Main name will be propane and amine, or propane 1 amine, whatever you would like to write, or propane 1 amine, whatever you would like to write. So main name is that, and methyl group is bonded to the second carbon. So that's why we write 2-methyl. Here also we can write 2-methyl. So 2-methyl propanamine or 2-methyl propane 1 amine. So second isomer is that. This one and this one is which type of isomer is? This one and this one is of chain isomers. This two is of chain isomer. These are chain isomers. Okay, next compound, same, you can attach this methyl to this one. So that time structure will be it is also 1 degree amine. Okay, don't be confused by the chapter of haloalkane or of the alcohol. So this one here, and what's its IPAC name? Amino group is attached at second position. Here, 1, 2, 3, 4. So functional group is at second position. Because if you do the numbering from left to right, then the functional group is getting third position. So simply we will write butane to amine. So its name will be butane. E will replace by the amine. So at second position it will be amine. Okay, so third position, and now this one and this one is this compound and this compound. Okay guys, it's will be difficult for me to write on the board, so you to write by yourself. So this compound and this compound are which type of isomers? Position isomers. They are also position, this one and this one chain isomers. This one and this one also about the position isomers, because here in position is at first and here position of the functional group is second. So this one and this one is positional isomers, and this one is also positional isomers. This one and this one is chain isomers, because length of the chain is different. Okay guys, now let's see next isomers. So that was about 1 degree amine, that was the classification here. Now let's see this methyl group. You may also get bonded to this carbon. So during that course, what will be the IPAC name? So that will be this one. So what's this IPAC name? Here 1, 2, 3. That will be the numbering. So at second position there is methyl, and second position amino group also. So that will be 2-methyl, and here it is propanamine. Propane 2-amine, because at second position the functional group is present as well as there is a substituent. So that's why IPAC name is 2-methyl propane 2-amine. Okay. Now that was about class. We have drawn the isomers of primary amine. Okay. Now then after let's see about the secondary amine in the same way. NH2 here. So 4 carbon. So here one this one, and we can draw this one also. So here methyl is to this functional group. One side there is methyl and another side is propyl. So its length is small and its length is large. So name of the compound will be propanamine, and the methyl will consider as substituent. And here the methyl, the substituent methyl is bonded to the nitrogen. That's why we will write for this one as N-methyl. So its name is N-methyl propanamine. Okay. Then after next one here, take 1-methyl group also from here. Take 1-methyl group also from here and bond to this nitrogen. So compound will be okay. Not one in the secondary amine classify the other one also. In the same way, this side 2-methyl length of the alkyl group is of 3 carbon, and so another isomers maybe this one also. So this is ethyl. So N-ethyl, we will write N-ethyl ethanamine. So this is N-ethyl so IPAC name of this compound is N-ethyl ethanamine. Okay. If you take this methyl, then again this compound will form. So their IPAC name will be same, and they will not the isomers. they will be the different structure of the same compound. Now another one, take one methyl from here and attach to the nitrogen. So that will be so what's its IUPAC name here? Then this is of one carbon, this one is of, this alkyl is of one carbon. So this alkyl group is of one carbon and this alkyl group is of one carbon. So so this one will be considered as substituent and this parent name will be ethanamine. So name will be actually ethanamine. And the 2-methyl group is bonded to the nitrogen. So that's why we will write NN dimethyl. So it will be NN dimethyl ethanamine. It's IUPAC name. Okay. Now let's see about the isomers. This one and this one. Which type of isomers? They are here metamers. Length of the chain is different. Okay. That was right isomers exhibit different pairs of this one. Okay, guys. So that was about the introduction of the amines. In the next class, we will discuss about the method of preparation of amines. So it's all for this class. Thank you, Team Educate.